Good day. Now we will understand the various aspects of DC motors. Let's start with the principle of operation. So the principle of operation of DC motors revolves around the conversion of electrical energy to mechanical energy. So the input here is the electrical energy and the output is the mechanical. So in DC motors, the input electrical energy is supplied by a DC supply. The construction of DC machine is the same whether it's a motor or a generator. So as what I've said during our previous discussions that DC machines is similar when it comes to the construction if it's generator or a DC motor. And the statement for a DC motor states that when a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. So if you try to review the working principle statement of DC generators, it states that when a conductor cuts magnetic lines of force or the flux, we otherwise known as flux, an EMF is induced in that conductor. So that's for the DC generator. Whereas for DC motors, again, it's when a current carrying conductor is placed in a magnetic field. So we now have a current carrying conductor because the conductor in the armature has a current already because there is an input supply, okay, input electrical supply, and is placed in a magnetic field and it experiences a mechanical force. This mechanical force is the output. Okay, that's why the final output of this machine is there should be a rotating portion or rotational motion going on. That's for DC motors. So we will get to understand later what's this mechanical force. The armature conductors experience a twisting and turning force called torque. So because there is a mechanical force, so we also have here torque, and torque is the act of twisting and turning. So torque is the product of force and the radius at which this force acts. And since the conductors are placed in the slots which are on the periphery, the individual force experienced by the conductors is what we call as torque. Now let's try to consider the representation of a conductor in a magnetic field and the flux produced by current carrying conductor. So let's say this magnet here represents our field winding. So i-represent lang siya og usa ka permanent magnet. That is N pole and our S pole. So based on the characteristic of polarities, so it originates from the north and terminates to the south. So north to south ang directions ato ang lines of forces. So this represents our field winding kaning duha ka permanent magnet. And there's one conductor, and this conductor is the armature conductor. I-represent lang siya usa ka armature conductor. Now, that is a conductor in a magnetic field. Let's proceed to the second figure, flux produced by current carrying conductor. So since there is a current flowing in our conductor based on electromagnetism and loss of magnetism, there is flux around it if naa gani current gani flow sa usa ka conductor. So the direction of the flux sa atong current carrying conductor is based on Fleming's right hand thumb rule. So try to consider your right hand, then the thumb. Then the thumb points the direction of your current. So in this case, the direction of the current is going away from you. Okay? So gapalayo nimo ang current. So this is the I, the flow of current. And here the flux going to that direction is that is represented by your four fingers. Okay, the thumb represents the current and the flow of flux is represented by your four fingers. So if you try to consider your right hand, so make sure that your thumb is going away from you and your four fingers represents the direction of your flux of the flux. Okay, so that's the flow of the flux by conductor. Okay, now we will try to combine together the magnetic field and the flux produced by the current carrying conductor. So this is the representation, the third figure. So if you try to look at, there is nagsagol-sagol na ang atuang magnetic field, which is na-flux at magnetic field. At the same time, our current carrying conductor also has a flux. Okay, na-flux ang conductor na nasa tunga because current carrying conductor. That's law of magnetism. Now, if you try to look at, so the flow of in this portion, on the right portion, or left portion rather, na ay addition of flux. Pasabot nga that the flux nga going in the same direction will be added. Okay? Since the direction of the flux sa atong conductor is going upward, going to this clockwise, then it goes also together with the direction of our magnetic field nga N to S. Okay? So there is addition of flux or nag-combine or nagsagol-sagol atong flux. Whereas on the other side, on the left side, there is what we call as cancellation. Cancellation because the direction of your magnetic field is going to N to south and the direction of flux is going against your magnetic field. So padung sa ubos ang atuang flux sa atong current carrying conductor, whereas your magnetic field sa atong field winding, which is represented by the magnet, is going upward. So if you try to look at, there is an opposition, and that is what we call as cancellation as well. So in general, okay, this one, the last figure, so the force experienced by the conductor. So that's why if ato sa left na side there is gathering of flux, so pasabot mas kusog ang flux diri. And remember that flux are what we call as magnetic lines of forces. So force yeah. Whereas on the other side there's weakening of flux. So tungod sa cancellation, so ning weaken ang atoang flux on this side. Okay? So what will happen if weak ang usa, then ang usa is the other side is naay gathering of flux, mas kusog iyang force because of the addition, then what will happen is there will be mechanical force. So that's why the direction of force is going to the right. Okay? Tungod kay ani nagtapok sa portion nga gathering of flux. So that is the concept and principle why there is mechanical force going on for DC motors. There is addition and cancellation of magnetic lines of forces or flux. Now we will try to understand the torque exerted on armature. Now this time, the field winding is not anymore represented by a permanent magnet. It's already represented by really actual field winding. Nga ang direction niya is going to the left. With the use of right and thumb rule, we know that the direction of the flux is going downward. Okay, this represents as your four fingers the direction of the flow of current, and the thumb represents the direction of the polarity. So this is north, and sa ubos ang south. So if you try to put it here on the side, this is the direction of the magnetic field caused by your field winding. This is the north and the south. Now next is let's try to know the flow of flux sa tuang armature conductor or the conductors kani. This is the conductor. Now, ang X nag-represent nga padung sa away from you ang imong current. This is I. So if away from you ang current, then the four fingers, the flow of flux is going clockwise. Okay? Kaya if nagpa towards you pa, kung padung pa nimo ang I, sabot ang thumb is ka at bang nimo, then the direction of the flow of flux is going counterclockwise. But in this case, X nga symbol here represents nga gapalayo ang current nimo. Okay, so let's try to draw here the flux. The direction is clockwise. So this is the flux and upward from N to S, this is your magnetic field. Okay. If you try to look at, so for the right side, okay, for the right side, what is happening sa tuwang flux and magnetic field? So the direction of flux is going clockwise man, and the direction of the magnetic field is going N to S. So opposite ang direction sa duha. Therefore, there is cancellation nahitabo sa tuang right side. But sa left na side, okay, the left na side, the direction of flux is going clockwise, and the direction of your magnetic field is also going downward. Okay, it goes with the same direction. Now, therefore, since they go together, there is gathering of flux, which we call as addition. Okay. So, pasabot, since baga ang force dire sa left side, and there is weakening of flux going on sa tuwang uh, left, or nabaliday, this is right. Sorry, this is right, and this is left. Okay. So, there is addition going on sa right side, then sa left is na cancellation. So, therefore, the direction of the force is going to that direction. Okay? So, muna si torque. So, the twisting and turning is what we call as the torque. Okay? So, torque is equal to the force times the radius. Okay? So, that's why in this representation, the force is going to that direction. Okay? Now, let's consider the different scenarios of our conductors and magnetic field. For A, what happened is that the direction of force is going to the right. Why? Because the direction of this is the magnetic field, and your flux sa tuwang conductor is going, since it's away from you man, so going clockwise. So sa left na side na ay addition nga nahitabo, wherein in the right side there is cancellation. Kaya nag-opposite pa na itong flux and magnetic field. So that's why the flow of force, or the direction of force is going to the right. Whereas for letter B, the same imuhang magnetic field, okay, the same ganina, the same magnetic field, ang na-change lang is the direction of your flux. Pasabot sa naay dot is the direction of current is towards you. Okay, atbang nimo ang thumb. And your four fingers is going counterclockwise. If you try to look at, there is gathering of flux going on sa right side, whereas sa left side is cancellation, kaya nag-opposite siya sa atong magnetic field o ng flux. So since na ay gathering of flux on the right side, so the direction of the force is going to the left. Okay? So padung sa left ang atong force. Next is atong gi-change ang magnetic field. So N and S, so going downward, and the direction of the flux is going clockwise. So what happens is there's gathering of flux on the right side. Kaya pareha sa log flow sa magnetic field, and flux it the same sa log flow. So the direction of the force is going to the left. And next, the same magnetic field but different ang flux. So the flux is going counterclockwise for letter D. Okay, because the direction of EMF, the current is towards you. So the four fingers represents nga padung siya sa counterclockwise. So in this case, since counterclockwise, there is gathering of flux going on sa tuwang left side. And sa right is na weakening of flux, therefore the direction of force is going to the right. Okay? So these are the scenarios and cases nga if ma-change ang magnetic field o ma-change ang flux. So therefore, the key point here is in practical motor to reverse its direction of rotation. Either direction of main field produced by the field winding is reversed, or the direction of the current passing through the armature is reversed. So there are two possible ways nga you can reverse the direction of the rotation of your motor. Pwede nga ibalihon nimo ang field winding, ang magnetic field, or pwede pud nga balihon nimo ang direction sa imuhang uh, current nga passing through the armature or the current carrying conductor. And what will happen if balihon nimo ang duha, so pareha gihapon way mahitabo. So naa usa nga mabali. Okay? This is for the direction of force experienced by conductor. Next is the significance of back EMF. Now, EMF or electromotive force, we understand this term sa DC generators wherein na ma-induce ng EMF. The question here for DC motors is that is there an EMF produced sa DC motors? Kay motor na biya siya, so the output is mechanical. Anong na EMF? The answer is yes, there is EMF still produced for DC motors, but we call it back EMF. Okay? Why? Because if you try to understand, uh, the idea for DC motors is that when a conductor cuts the lines of force or flux, EMF is induced in the conductor. So pasabot, if we have a magnetic field or the flux sa atong field winding, then we have conductors sa atong armature and there is a relative motion, then we could have a generating action. Diba? These are the three important aspects for the generating action. Now, let's try to focus on motors. Ang motor na siya magnetic field, diba? Caused by the field winding. Then, si motor na po siya conductors, ang atong armature conductors. Now, after the what we call as the motoring action, katong makatuyok na siya, then there is relative motion. So if naaning tulo, therefore, there is what we call as generating action going on. So, si magnetic field, katong si conductor, makakat siya og lines of forces sa tuang magnetic field kay makatuyok naman siya caused by torque sa atong mechanical force nga na-experience sa atuang armature conductor. So once makatuyok na to siya, at the same time, nag-cut pud siya og mga lines of forces sa atuang magnetic field. Okay? If mag-cut siya lines of forces, so based on this statement, then ang atoang conductor or the armature conductor is also inducing EMF. So na po siya induced nga EMF. Okay? After a motoring action, there exists a generating action. So mo na kung giingon nga after na makatuyok or maka-experience of mechanical force, our conductors also cuts lines of forces from our magnetic field. According to Lenz's law, which states that the direction of the induced EMF is always so as to oppose the cause producing it. So remember in a DC motor, 'di ba sa DC motor kay gikan siya sa armature nga naka-generate and mudong siya sa load side or the terminal voltage. In this case, for the DC motor is supplyan ang ato ang terminal voltage since the input is electrical energy. So the flow of current is from the terminal voltage going to the armature. Then, remember sa based on the statement of back EMF na ay maproduce ng EMF sa tuhang armature. But based on Lenz's law, okay, which states that the direction of the induced EMF is always so as to oppose the cause producing it. So the direction of your back EMF is opposite to the direction of your input voltage. So kung yung input voltage is going padung siya na ang direction, the back EMF is going opposite direction. Okay? So that is the significance of back EMF. So this EMF always opposes the supply voltage. That's why it's called back EMF and denoted by the symbol E sub B. Though it is denoted as E sub B, basically it gets generated by the generating action, which we have seen earlier in case of generators. So the same with the magnitude, we can calculate the magnitude of this induced EMF by the equation nga Pn phi z over 68. So the same as siya kay it's the same electrical machine or DC machine. So the formula for getting the back EMF is the same with the generated EMF from the generators. Okay. If you try to look at the equivalent circuit, so this is the supply input voltage, okay, or the terminal voltage, and the terminal voltage we have it flows right through the armature conductors. Then, once makatuyok na, then that's why maka-establish ta og back EMF. Now, let's proceed to torque equation. As what I've mentioned, torque plays a very important role in DC motors because this is the act of twisting and turning of our conductors. So we have here the Now let's proceed to torque equation. As what I've mentioned, torque plays a very important role in DC motors because this is the act of twisting and turning of our conductors. So we have here a rotation, okay, which has a force going to this direction and the radius. Okay? Mo niya to ang mga conductors and the radius. So ang force kintahi is going to that direction or clockwise. So torque is equal to force times the radius. Force is in Newton and radius is in SI unit is meter. So the SI unit of torque is Newton meter. Now we have here N, which is speed. Okay, kay motuyok man nato ang motor, so speed really plays an important role. So speed has an SI unit used in DC motor in RPM or revolution per minute. So if you try to convert this to angular speed, this is angular speed, which has an SI unit of radian per second. Okay. So try to convert. N is in revolution per minute. So that's N. In one revolution, para ma-cancel out ang revolution, you put it below. So, one revolution, there is 2 pi. So, muna ang mag-represent sa to ang radian. So, si 2 pi muna ang usa ka libutan sa circle. One complete revolution for a circle. Next is 1 minute, 60 seconds. So, cancel out cancel out minutes and also with the revolution. Okay? So, unsay naibilin, it's 2 pi over 60. And kaning si revolution per minute, di ba mao man ni si n. Sabot, ang n kuno multiplyan og 2 pi divided by 60, that is already angular speed in radian per second. So angular speed is equal to n 2 pi over 60. Or if you try to rearrange, it's 2 pi n over 60. That is already your angular speed in radian per second. So here are some important equations that are useful in solving torque equations. So power is equal to torque times the angular speed. Okay. So this is the power sa tuang armature. Kay since si armature man ang mutuyok, so if we multiply torque sa tuang angular speed, then we get the value of power in watts. Okay. The unit is watts. So power in the armature is also equal to, if we try to continue, that is EB or the back EMF times the armature. Okay, since armature man, so if you multiply the EMF in the armature, that is the power developed sa tong armature. That is equal to the torque. Okay, torque sa armature, so let's just put TA to represent its torque sa tong armature multiplied by our angular speed nga omega. If you try to substitute the value, that's 2 pi n over 60. And if you substitute the equation for our EMF, so that's P and phi z over 60A multiplied to IA is equal to TA times 2 pi n over 60. So if you try to simplify the equation, okay, na yung makancel. So the final equation is TA is equal to 1 half 2 pi flux times IA times PZA. Okay. So this is the final equation of torque sa tuhang armature. Okay. 1 over 2 pi times flux times the armature current times the number of poles and number of conductors na Z divided by A, or the number of parallel paths. So this is the torque equation of a DC motor. So you can use this formula or the second formula. It depends on the problem. Next is there are types of torque in the motor. So we have armature torque or the generated torque muna sa TA. Muna yung na-generate nga torque sa tuang armature. Then we have also lost torque and the shaft torque or the useful torque. So this is the mechanical power developed in the armature is transmitted to the load through the shaft of the motor. So it is impossible to transmit the entire power developed by the armature to the load. So pasabot katong gross mechanical energy, this is the mechanical energy na makuha sa tuang armature. So dili gyud nga mo dito siya equal sa tuang output ng mechanical energy. There is what we call as losses or the lost torque because of stray losses, friction, windage, and iron losses. So mo is the gross mechanical energy and this is the output mechanical energy, and in between during the process so naatay what we call as losses represented by the lost torque. So therefore TA or the armature torque is equal to TF. Si TF is represents sa ato ang shaft torque, which is what we call as the lost torque, plus TSH or the shaft torque. Okay, ang TF di is what we call as the lost torque represented by TF. This is lost torque losses, and this is shaft, and this is your armature torque. Okay. So mo ni ang equation sa ato ang torque with respect to the losses and the useful torque. So ang useful rani is si shaft. Okay, since this is the output, mo ni ang losses and the armature. So this is your input. So therefore, since ang magamit naman gud ani is si useful torque is TSH or the shaft torque, so therefore the net output power sa tuang motor is equal to P out is equal to TSH or the shaft torque multiply sa tuang angular speed. Okay? This is the P output. So kaning P is equal to torque armature times the angular speed. Sumahog ni nga mo niya to ang input power. Okay? Input mechanical power. Whereas kaning P output, we will use the torque sa tuang shaft since it is what we call as useful torque. Now let's proceed to no load condition. So on no load, the load requirement is absent. So since no load man, the useful torque TSH is equal to 0. Kay katong TSH or the shaft torque, that is the useful torque. Since wala may magamit nga load, okay, di man magamit ang atuang torque for the load side, so okay, because of no load, then TSH is equal to 0. So atong torque equation, TA is equals to TF plus TSH. So si shaft torque or the useful torque is 0. Therefore, your armature torque is just equal to TF or the loss torque. So mga losses ni windage, friction, stray losses. So therefore, di ay at no load condition, ang ma-develop na torque sa tong armature is just enough nga mo equate siya sa tuang losses. Okay? Kaya wala may useful torque, kaya may load. So therefore, power developed nga E sub B na naay O times I sub A. O, the O here represents nga no load condition is just equal to friction, windage, and iron losses. Okay. So the motor draws less current on no load and takes more and more current as the motor load increases. So at no load, enough ra ang current nga at no load ug ang back EMF at no load nga mo suffice ato ang friction, windage, and iron losses. So that is the condition for no load. So ang timaan ninyo for in solving no load equations or no load condition, there should be a subscript nga O, okay, that represents the no load condition. So we can also say TA or the armature torque at no load, can I sub O is just equal to TF or the loss torque. So if you would multiply kaning back EMF ug ang armature current at no load, then ang gawas anang answer is equal to the power losses, stray losses, friction, windage, and iron losses. Now, this is the circuit diagram of a DC shunt motor. So sa DC shunt motor, same goes with DC generator. So since it's shunt, na ay nakaparallel sa tuhang armature. So the key, ang yung timanan lang ani is the flow of the voltage or the current is not anymore the same with generator. So kung sa generator nag-start sa armature, ang flow sa atong current is nag-start sa armature. For motors, nag-start na gud siya sa terminal voltage. So this is now the flow of the current. So this is IL, then ISH, and IA. So based on the circuit, so we can have ILDI is just equal to IA plus ISH. Okay, that's for shunt. And if we try to get the voltage drop across sa atong circuit, so if mag-loop ta, diri ta mag-start sa atong supply voltage going to our armature. So since nag-start ta sa supply voltage, so V mauna, V minus IA RA, kay mulabay man ta sa armature. Then minus the back EMF minus pa if na brush voltages. Okay? Voltage drop across our brush is equal to 0. If you transpose the other side, atong supply voltage di is equal to IA RA plus the back EMF plus the supply plus the brush voltage. Okay? So this is the equation, voltage equation sa tuwang shunt motor. Next is the DC series motor. So the same construction with DC generator ng series, it's just that ang flow sa itong supply voltage is different. It's going from supply voltage to the armature. So na naka-series nga resistance. So since it's series, your IL or the load current is equal to ISE, the current na ni-flow sa tuwang series resistance, and that's also equal to our armature current since naka-series man siya. So for the supply voltage, V is equals to EB plus IARA plus ISE RSE plus V brush. Or we can combine kay since IA and ISE kay parehar man sila, so we can factor out EB plus IA RA plus RSE plus the voltage drop across the brush. So this is the equation sa tuang DC series. Next for the DC compound, so it's it. So DC compound na po siya ay long shunt and the short shunt. So in this case, since our series resistance kay RSE is nakakonect siya sa armature, then this is what we call as long shunt compound motor. So sa long shunt, tanaw ni mo ang flow sa direction sa voltage, IL. IL is equal to ISH plus IA. Kaya kaning si ISE nga ni flow dire, ISE, that is just equal to your IA. Kaya naka-series man mo ang RSE sa tuang armature. Okay? Now to get the ISH, so ISH is equal to V over RSH since naka-parallel man si shunt sa ato ang supply voltage. So the same gyapon ang voltage equation. So if mag-loop ka dira, mag-start ta sa V. So V is equals to EB plus IA RA plus ISE RSE. So the same ra siya sa ato ang series motor. Next is for the next type of compound motor. This is the short shunt. So sa short shunt, si series winding is connected in series sa tuang supply voltage. So we try to redraw i-draw to balik. So this is your armature, the armature winding. This then we have the shunt, and this is your series. And this is your supply voltage. Okay, this is RSH. This is RSE. And this is your RA. And this is your back EMF. So kani siya nga circuit, it's just similar with this circuit. So lahi lang siya pagka represent. So this is your supply voltage or the input voltage. So the flow is from the supply voltage, then tunga siya sa atong ISH, and also with our IA. Okay. So in that case, IL is equal to ISH plus the armature current. Now, to get the voltage equation, V is still equal to EB plus ISE RSE plus IA RA plus voltage across the brush. So, if anak ka mag-loop, nag-start ka sa V, then na siya voltage drop across the resistance, so that's why ISE RSE, where our ISE is equal to IL. Kay naka-series man siya sa tuwang load voltage or naka-series siya tong supply voltage. So ISE is just equal to IL. Okay? Then mo-flow siya sa armature, then going to the back EMF. Now to get the ISH, okay? To get the ISH is kinahanglan ka mag-loop from V to the RSH. Okay. To get ISH, okay, if mag-loop ta, diba ISH is equal to the voltage na nakaparallel niya divided by the RSH. In this case, na naman tayo voltage drop across the series resistance. So if we try to, if mag-loop ta or we sum up all the voltages across ani nga loop, okay, nag-start ta with V minus the ISE, RSE, okay, minus the voltage across the shunt. Okay, ang mo flow ani, that's voltage across the shunt is equal to 0. Or V, or supply voltage, minus ISE, RSE. So maning shunt, voltage across the shunt, that's ISH, RSH is equal to 0. So i-transpose nimo to get the value of the ISH. So transpose on the other side. So that becomes ISH is equal to V minus ISE RSE divided by RSH. So, unlike with the DC generator nga naka-plus ni siya, diba? I-add mo ang voltage drop across the resistance nga naka-series ato ang load voltage, i-add siya para makuha nimo ang voltage across the tawag ni across the shunt sa iyang parallel niya divide by RSH para makuha si armature current. So sa DC motor is naka-minus. So V minus ISE RSE divided by RSH. So next is the torque and speed equations. So from the torque equation, which is TA is equal to 1 over 2 pi flux times the armature current times the number of poles and armature conductors divided by A, or the number of parallel paths. So if kaning si pole, armature conductors, the number of parallel paths, kaning 1 half 2 pi, if makonstant ni siya, so may bilin lang yun is flux in your armature conductor. So that's why torque is directly proportional sa tong flux in your armature conductors. Kay kaning si pole, number of conductors constant man ni siya, di man ni madali og ilis ang changeable lang gid ani nga pwede ma-alter is kaning flux and your armature current mo ni dali nga ma-change. Now, we also have equations or relationships nga useful in solving different problems, especially if ang problem can ay two scenarios. For example, nag no load, then full load. So we will use N is directly proportional to the back EMF over the flux. So asa may basihan ani, that is from the EMF equation na Pn Pz over 60A. So si P, si Z, and kaning 60A, let's say constant na siya. So ang mag-change na lang ani, pwede mag-change is ang speed, which is N, and si flux. So EB, or the back EMF, is directly proportional to N and the flux. So pasabot kung mataas ang value ni speed, so mataas po ang value ni back EMF, or in balipod, mataas ang value ni flux, mataas po ang value ni back EMF. So by arranging, so moabot siya nga aning equation. N is directly proportional to the back EMF but inversely proportional to the current. So how do we use this sa mga problems? So let's say if natay N1 or pasabot N sub O kintahay nga 300 RPM, and we have N sub 1 or the full load which is 900. Yan, kintahay at no load na kay IA, or the current kintahay is equal to 5 amperes, but on I full load we have 60 amperes. Now at E sub BO, so pasabot the back EMF at no load, which is equal to kintahay 100 100 volts kay gamay raman. So mingon ang problem, find the back EMF at full load. Okay, so muna ang scenario, this is Case 1, so the same machine rin siya pero naglahi-lahi ang value. That's why we can use this kaning relationship. How do we use that? By ratio and proportion. So we say N sub O over NFL is equal to, so direct proportional siya sa EB. So that's 1 EB sub O divided by EB at full load. This is at full load. Then multiply 2. So since inversely proportional man siya, so ang N sub O is dapat na siya sa ubos. So atong IA na sub O, okay, IA sub O, then sa taas ato ang IAFL. Okay. Muna ang paggamit sa tuang relationship sa torque and speed equations. Okay, remember si flux, okay, flux is directly proportional na siya sa ato ang current. So instead of using flux, so ang mag-given gina is in terms of current. Kaya ang flux is nagdepende pud sa amount sa current. Okay? So dapat si N sub O ug si EB sub O pareha man sila nga at no load, so directly proportional siya. But ang tungod yun sila, pero ang si IA sub O is nasa ubos because it's inversely proportional with our speed. Okay? So that's why bali ang pagsuwat sa tuang current, which is represented mo na nagrepresent sa tuang flux na inversely proportional sa tuang speed. So these torque and speed equations or mga relationships sa tuang back EMF and sa tuang speed and sa tuang torque, these are very useful in solving problems and ay mga changes sa tuang speed o sa tuang back EMF.